geology, there is a rather niche and advanced feature called a barbed tributary. And in this case, it's a barbed canyon. And right next to it, there's another barbed canyon. And they tend to form like this where they're close to each other. And this barbed canyon, or barbed tributaries in general, are seen by scientists as a way of indicating that a current direction, reverse direction, that the river actually, this is apparently evidence that the river flowed in the opposite direction, 180 degrees opposite of the way it flows today. And I'm going to explain that theory, and then I'm going to disagree with it, and then I'm going to show you how they're actually interpreting it 180 degrees off. Okay, so this is Arizona. This is the Great Expansion Bar right before the Great Canyon that they call the Grand Canyon. A lot of river terraces on there. So this is a great example of a barbed tributary and a barbed canyon. And they believe this is actually indicating that the Colorado River actually flowed this way. So let's take a look at what Google has to say about a barbed tributary. A barbed tributary forms when a river reverses its flow direction, but its tributaries continue flowing in their original direction, creating a barbed appearance. This usually happens due to river capture or other geological events like tectonic activity. So what's river capture? A river can be captured by another river, meaning its flow is diverted to the new river's course. Okay, this part's good here. In simpler terms, imagine a main river flowing from west to east. Right, from west to east. If the main river changes direction and starts flowing east to west, but the tributaries still flow from west to east, then you have a barbed tributary pattern. Okay. So we're here in Russia, and we find a lot of parallel streams, parallel canyons, a watershed full of parallel tributaries. So when we zoom in on this, we can see that they kind of come together. The way they, for example, when you look at this, the tributaries, if this is the mainstream, these tributaries are meeting the mainstream at basically a 90-degree angle. Okay? That's very common. But in this landscape, we also find how they branch together and they come together. That's a normal herringbone pattern. Okay? The tributaries usually come at the same angle or at a slight angle with the mainstream pattern. Okay? So that's what we find with this. Now these are not, because these come together like this and go downhill, that's not a barbed tributary. But if it was flowing the opposite way, right, so you see this nice U-shaped pattern? If the mainstream flowed this way, then that would be a barbed tributary. Okay, so I hope that makes sense. So we find a lot of U-shaped features on this landscape. And look at this. It looks like it's extremely terraced. And it looks like Glen Roy. You know, Glen Roy's parallel roads. The parallel roads of Glen Roy, I'll let you in a little secret. They're actually river terraces. Just like all of these are actually formed from river terraces. It's an incredibly delicate pattern. Only water can preserve. And all of these lakeshore lines, these are built up sediments in what is called an accretion ridge. Okay, so that's just a little background into this pattern here. Now let's look at how this is all parallel. All these All of these are parallel, but here's the mainstream, right? This is the big river of the area. And why aren't the tributaries meeting this? It's almost as if these two watersheds really have nothing to do with each other. Now, let's go back to this idea of what they call the river capture. How can this be? How can you capture a river? Well, let's say, actually, I'm going to go to a place in China. That's going to be a good example. Okay, so this is a great example of a barbed tributary because you've got the mainstream coming down this way, and instead of, what happens is it hits this and it branches off of it. It's almost like that's a streamlined feature, right? And then it's like over here we find another streamlined feature. And then this larger feature here, this is the way the water flowed. And then it branched off around a landmass. Okay, so that's a barbed tributary. Okay, let's go, and then we look at this one over here. We start to find, U-shapes in the landscape, U-shaped features. Okay, let's go to the Indus. Okay, yeah, so if we go here, let's look at some examples. The top examples, you have the Indus River, you've got Canada, Colorado. I've already showed you the Colorado, Marble Canyon, that's where I showed you. There's some spots there's a good spot in Nebraska and Missouri I'm going to show you. So these are the top spots for barbed tributaries. Let's go to the Indus River. It's a good example. So, all right, the water's flowing downstream here. And then it comes to here and it branches off and goes around it. And then the stream's coming down here and it branches off and goes around it. Now they're saying that they think that the water current actually flowed this way and that they came together in the normal herringbone pattern. Right, so when you orientate it this way, you find that it's most common for something where they come together like this. Right, streams connect and the mainstream grows that way. But instead, these are actually streamlined around a landmass. Got streamlined here. Okay, let's see this location. Same thing where we kind of see a streamlined around here. Now there's a good location here. Just look at that, it's pretty cool. These are also massive ripple patterns. Just to get you an idea of what sort of landscape we're dealing with. We got ripples almost 1.4 miles. And pushed sediment features on top of them. And that's what these are all too. And these have ripples on them as well. It's all fluvial. Okay, and now let's check out these here. These are the canals now, but they are the low spot in the landscape where the river once, or the water once funneled. And we see how they abruptly begin into a U-shaped streamlined feature. Right, another streamlined feature. So this is not actually a barbed tributary because it's flowing down this way and it's connecting somewhat like the herringbone pattern. Except for the difference between this and the herringbone is that the herringbone has a mainstream in the middle, while this doesn't. So it's where did this river come from when it equally met? That's the big difference between the herringbone and the streamlined features. So we have parallel types of watersheds where they come together like this. This is the normal way to see it. That's how it should be. This is how you should be. So this mainstream is always flowing this direction. Now, I told you in the beginning of this video that they actually understood understood the water level or the water direction completely differently. And I'm going to explain that. So let's just go to this spot to Nebraska. I'm just going to, when so many people explain topics, they only show like, one photo. And, I try to separate my channel from that by just showing you so many locations around the world so you get a real idea for the real evidence, right? That's what it's about. You can disagree with my theories, but if I'm showing you real evidence, then I find that to be beneficial nonetheless. So here's an example. This mainstream flows down this way, but this was referred to as one of the rivers that have tons of barbed tributaries. So I think they're referring to these U shapes, right? Because they look just like the barbed tributaries. And then if we look at some patterns in here, what sort of landscape is this? Well, we know those are mounds. Now, I still can't tell you for certain if these are ripples or drumlins. Depends on which way the current flowed. And I think that, when they overlap into mounds, that's when it's the combination of the both. But this gives us evidence that they're actually ripples when we see this. This is a directional feature. This being the scarp edge, which is on the leeward side of the feature. You can find these in rivers. This also being a U-shaped feature, right? So the current flowed this way, which would then make these massive mounds, massive ripples. See if we can get a wavelength on it just to get background idea of what sort of landscape we're on. 1.18. I'd say it's pretty decent. And people that have been to these landscapes say that it's incredible how these features begin really abruptly. So the land's all flat, perfectly flat in the valley. And then very abruptly, these massive features begin. Then it goes back into a trough, which even has lakes in it. And then let's see if we can find evidence that they're drumlins, which means that they formed parallel. Well, then we find, that's not the best example, but if we find sediment lobes going this way, then that would indicate that at least there was a later current that went parallel with them. Let's see. Okay, here we find some pushed sediments. We can see that this is the front edge. Now this is the scarp edge, which was also leeward, but the parabola is shaped a different way than the other feature I showed. But both of them can be found in rivers. So here we can see the sediments. Kind of get a current direction going with the ripples here. But anyways, back to what I was talking about. Or this right here is a big streamlined feature here. Maybe that's the big barb they were talking about. And then maybe we go this way. Somewhat of a barb. Okay, I believe this is near the Wisconsin River, which was also on the list. And we kind of run into a U shape here. Run into another U-shaped here. And remember, there's no mainstream in the middle of these. No mainstream in the middle of these U-shapes. So I think you guys are going to start to figure out what my theory is on how these actually formed. I guess I'll show you this spot. Oh boy, look at this. First of all, just take a look at all that erosion. Big double cataracts, river ruts, expansion bars that curve out. Classic stuff. Of course, it's all attributed to an ice sheet, but I don't buy that. Let's zoom in, see what we find. Ooh, those are nice. Look at the streamlined shape. Oops. Perfect streamlined, perfect streamlined, perfect streamlined. So this is how, what barbed tributaries are. They're streamlined features. So you have the water current streamlining around these features. Now hold on, because it gets crazier. I'm not done. Explain this. Why are all these... All right, so with laminar flow, that's when water forms in paths with the current. That's the force that's responsible for all of these being parallel. And it doesn't have anything to do with this mainstream here. Okay? Now we keep that in mind and we go back to our original spot, which is right here in the middle of this amazing expansion bar, almost 13 miles wide, right? And what do we also find, just like in Russia? It's hard, you can't quite, here you go. We can find parallel tributaries, right? Why do these form so straight? Okay, and why are they so parallel? Because they are formed under sheet water flow. Now, with this original idea of, let me open this in a new tab. With this original idea of the water current reversing and the idea of the river capture, I don't understand how they think that's physically possible whatsoever, because if the tributary is uphill of the mainstream, right? So let's look at this. Colorado River's flowing this way. How is the Colorado's river direction going to have anything to do with this canyon being formed? Right? It's occupying a completely different space. So whether the Colorado River flows this direction or this direction, if the Colorado River is within the riverbank, which is exactly, 0.6 miles wide or so, they stay in the riverbank. There is no way, whether the current is going north or south, west or east, it's not even touching the tributaries. So how has it changed the tributary direction? That would only make sense if you were under the sheet water flow model, which they of course aren't, but they should be, because then they'd understand the erosion of the earth a lot better. So they're not even under the sheet water flow model. So how does the tributary direction have anything to do, or how does the mainstream have anything to do with the orientation of the tributary? How can it be a river capture? If this river's in the banks, how is it capturing the tributary, right? It makes zero sense. It doesn't even make any sense in physics. It's obviously not reproducible unless they were in the sheet water flow model. Then it would be perfectly reproducible. But once you understand the sheet water flow model, you will understand what this feature is and what the barbed feature is and why they're 180 degrees off. Okay? This is an expansion bar on a cliff edge. This happens when water is focused and it wants to expand. So the expansion bar is a directional feature indicating, how this led into the Grand Canyon. Okay? Now, the barbed tributaries denote the exact same direction because it's a streamlined feature. See how perfectly streamlined it is? This canyon, which begins abruptly, over here it's almost nothing. And then right here, it's a massive canyon. All this canyon, it wasn't carved by rainfall over thousands of years or millions of years. It was carved by a current streamlining it. And so every time you see a streamlined feature, think to yourself that or every time you hear about a barbed feature, think that it's a streamlined feature. Now, the most famous example of a barbed tributary denoting a reversal of the current direction is the deepest canyon in the entire world, or North America. This is deeper than the Grand Canyon. And it also has barbed features, 3 of them. 1, 2, and 3. And you can see how this comes around to even complete the streamlined shape. These are complete streamlined shapes. They don't have anything to do with a river capture or a reversing of the ocean current. So do you guys see how they have the current direction completely off? Because supposedly, because this enters the mainstream at such a degree, that would indicate, according to the herringbone, that would indicate that it went with the mainstream. So that would then indicate that the mainstream flowed this direction. Right? So if we see, or excuse me, I guess that's not a barbed one. That's my apologies. This one would be barbed. At this part of it's barbed if it hit the mainstream there. But you see how it's coming into it this way? According to the herringbone, the mainstream would then go to the south. So apparently this increases at the mainstream with this direction. So that's a huge indication that there was some massive flood up here that caused the current direction to reverse. And the Snake River currently flows north in this part of the canyon. So, yeah, they've got it 180 degrees off, and they're 1,000 times too small on the catastrophism scale to understand that these are streamlined. Let's go. And then, so yeah, let's just look at more streamlined. You have to understand that the entire, basically all of Canada has streamlined features all over it. All of these are streamlined. So if you study, the Earth as much as I have, you will know that there is so much landscape that is full of streamlined features, right? So that when you see a streamlined feature on a river, you can understand that it's not a barbed feature, but a streamlined one. So we got the drumlins, we've got perpendicular drumlins, we've got the ripples, right? This is this has everything right here. Ripples perpendicular to the current, drumlins parallel with the current, streamlined features pointing into the current, right? See all these? And then one more, parallel ravines, parallel rivers, or whatever you want to call these things, and they go right under the ocean level. And it's a very scratched up surface. This focused erosion is not something a glacier can make. A glacier can't focus its energy, nor can a glacier, nor does a glacier have the principle of parallel streams. But of course, sheet water flow, due to laminar flow, the principle of laminar flow in fluid dynamics, is going to naturally want to make parallel streams. Okay, so I'm just going to now start showing you streamlined features. Also, you go into, like for example, over here. This is a fantastic spot. You got streamlined features all over the place. And you've got ripples. And there's some good ones on this side. This is a good one. And you can also, if you look carefully, you can find these streamlined features went both directions. Let me see if I can find one of those. Okay, here's one. Here we got a U shape going the other direction. Right, so I do think there's a lot of evidence to support that ocean currents went back and forth over the land, creating U shapes in both directions. If you study this landscape long enough, you'll find that out for yourself as well. Here we got a lot of U shapes, but we can see a dominant direction in a lot of places. This is a dominant direction, but we keep looking and we can find ones going the other way. I thought I saw one going the other way. They're out here. They're a little more rare. Oh, here's one. This one's going the other way. And perfect ripples. So it kind of gets obvious, but you have to study it for a while for it to become obvious. So I appreciate you guys for watching my videos. And also this feature here is cool, how water went around both sides of this to kind of carve it out. And then you got drumlins on top. Now let's look. I'm running low on pins here. Oh, I know where we can go and find one no sweat. If we go to Norway, right? Massive one right here. Let's get a little width on her. 13 miles. I'd say that took a massive current to form. Here's another one. Really, you can find them all over Norway and all over Canada and Alaska. But this area in particular is pretty cool. We found a nice one here. Here. So this one, what sort of current is this indicating? Well, they face into the current. That's what a streamlined feature is. So it's actually indicating a current that washed through these mountains. And that explains why there's so many rutted out mountain passes. Right? So in order to pass through the range, you don't even have to climb a mountain peak, but you can paddle a boat across the mountain pass because it was carved through as a trough. So yeah, big erosion. And the idea of parallel streams, also, you got parallel streams or parallel canyons going through the mountains. So what carved the mountain passes is sheet water flow going back and forth. And that's why you've got such streamlined and such rutted out features. And also you find a lot of features that completely encircle a mount. So a great example of that is in Canada. There's a lot of them, but you can see how this wasn't completely encircled. Then when you zoom in, you can read the river terraces. And something like this, right, was also shaped around in a streamlined way. And then you can go up here and find, something like this, where you've got a perfectly streamlined feature carved out. But if you really want to talk about a perfect streamlined feature, we can look at this guy first, right? Streamlined like this. But this is the perfect one. That's a nice one, huh? We zoom in. We find parallel streams wrapping around it just as we'd expect. These streams aren't going downhill, they're wrapping around it because that's how the current formed them, from a current wrapping around. I'll take you to a really good. Actually, I'm going to go to Australia first. Australia. Okay, so this is how you find it on Australia. You look for the salt skull right here. Then you go up to the Mohawk and you find some insane drumlins. And this whole area is filled with salt pans. Ooh, look at that streamlined feature. So it's almost as if the streamlined feature is because the drumlins are from sheet water flow. Huh, I thought it would have been from an ice sheet. Now, what type of sheet water flow leaves behind salt? Because the ice sheet definitely doesn't leave behind salt. Now, that direction is the exact opposite as another massive streamlined feature. Find right next to it, not too far. But these are the big boys. All right, you can even see some. Those ones aren't as clear. This is the best one here. Right, so there's no middle herringbone. And now this current flows down this way. Looks like you get a nice decent canyon over there. So check this out. Expansion bar, drumlins, streamlined feature in the path of the drumlins, then one more streamlined feature, and some sort of with these little ripples on top. So it's all fluvial. It's all about fluid dynamics. You don't have to learn anything about ice because it's a solid object and it doesn't do much. It melts off and doesn't even disturb the mounds below them. What are these little lake basins? All in dots parallel with it. It's almost as if these are carved out from the undulating force of a water current. Huh. Now we're going to contrast this location here. Okay, let's get a visual one more time. And let's get a measurement. 20, almost 24. Okay, visualize this. Expansion bar, streamline, streamline, streamline. Okay, now you got that. I'm going to take you to Russia. Clearly sheet water flow came across there to form these massive parallel rivers, and also the parallel features that they call drumlins, right? So we get a lot of parallel water currents going through here, and then we zoom in and we find our streamlined features. Streamlined feature. Okay, so these are two really clean ones right next to each other, and you could even argue three. And this one kind of is asymmetrical like the one in Arizona. But let's get a measurement on this bigger one here. See what we're dealing with. 24 plus. So this is exactly like Australia. The erosion of Australia and Russia is nearly identical. They won't tell you that in the lecture, but I'll let you know about it. And then we also find streamlined mounds, clear indication of water washing over these low-lying hills. I recommend you check out this landscape for yourself. You just keep finding cool stuff. You find ripple patterns in river valleys. I mean, and then that's going to be right next to drumlins. And that's going to be right on top of mounds that also have mounds and ripples on them. All right, so they might call those eskers. But then you zoom out and you understand all of these features, even the streamlined ones, then that whole esker thing kind of goes out the window. This is a streamlined feature. This is a streamlined feature. This is a streamlined feature. And believe me, there's a lot more. This looks somewhat streamlined. We need an elevation map to really tell. But this streamlined one here is 36.8. That's pretty decent, I'd say. All right, with that, I'm going to end the video. I appreciate it. And I'm going to talk about this location more in upcoming videos, so you have to stay tuned to get the full understanding of this location and its many features. I'm also going to discuss Carolina Bays soon, and also Kazakhstan is insane. I got to get to that too. Plus, this is a 6 spot for drumlins. I got that on my radar with the little expansion bar. So yeah, stay tuned and hit the subscribe, hit the like, and leave a comment if you have any questions, if you learned anything, or if you got a place you want me to check out. I might just make time to make a little video on it, so I appreciate it. And I appreciate the support. And I always encourage you guys to go on Google Earth and look at what the real evidence is for yourselves. All right. Thank you. Bye.